I appreciate again the opportunity to come out to talk with you guys. I guess the planning committee really wants to get work today, so hopefully you get somebody's work. You came to my talk yesterday. I appreciate you coming back to hear me again. If you didn't see me yesterday, have interaction. So if you guys have any questions, please ask. I think if you guys have something on your mind, I guarantee someone else does. And so I think we all learn from that. Okay. Talk about kind of breaking bean barriers to the next generation, whether it's the kitchen sink or whether it's just back to the basics. These things we really got to get laid out first before we can really. I won't repeat that. What else? Nitrogen. Photosynthesis. Okay. Okay. So if you were to pick one management strategy to set the bar for high yield potential, what do you think? Something that you as an advisor, as a farmer, you can have control over. Even though we've got environmental issues, we've got and nutrients, okay. Water, some irrigators are going to play. Let's take irrigation out of the picture on this one. Just help. Okay. Management strategy. How many things should back to some real basic genetics part of this discussion. How many think it's I just want to kind of set the stage. Again, we're going to go through some basics. We're going to go through some kitchen sink studies we've done over the years and some very new stuff that just came out of 2016 that I alluded to yesterday. So as you build this yield, right, you've answered some of these questions. And what we're going to follow up with is not the end-all be-all that everything that goes into yield, but these are some major aspects of management decisions that build soybean yield. All right, and it's in no particular order. It actually advances. There we go. Variety selection, right? You know, if you look at just the variety trials, or let's say you don't have as many variety trials now, you go. More or less. 10, right? So again, we made the comment yesterday about seeing a 10, 12 bushel yield response in soybean is huge, right? If you just make your decision on whatever variety, whatever's in the seed bag, I'm going to put out there, that could be a 10 to 15 bushel hit, okay? So it's basics, but let's think about it before we get into, okay, the kitchen sink aspect of this, okay? Variety selection, the genetic side of things. Whether that's coming into yield potential, you got some disease issues or some other cyst problems. You know, the vast majority of our cyst-resistant soybeans come from what source? PI 88788. 95% of our cyst-resistant beans comes from one source. And we're having that broken down left and right. Okay, do you know that? Do you know that your fields are like that, right? And so to select a variety that has a better source of resistance, such as for instance. Timely planting, I'm going to spend a little time on this because I think sometimes, like I alluded to yesterday, you know, we think about planting soybeans just whenever corn's done. That's a pretty standard procedure in the Midwest, and maybe around here as well, okay? So how do soybeans grow and develop? What do they respond to? Sunlight? Is it really sunlight? Day length? So it's whenever you guys have that sign that's got a spotlight on it, those beans stay green, right? Because it's disrupting the night length. We always talk about sunlight, but it's really about the night length. That's that photo period we're talking about. Okay, that is true. But what else do gentlemen? We can peg out corn GDUs, right? Can you do that with soybeans? Not so much, right? But do they respond to heat units? You betcha. You betcha. It's a mixture of that photoperiod that's pushing into flowering and reproduction as well as heat unit accumulation, okay? So our job is to really kind of trick the system to utilize as many heat units as possible before that photoperiod, that transition time, pushes us into flowering, okay? So I'm going to talk a little bit about that if I get past the second slide. Narrow rows, so I'm just going to kind of bust through a few of these and we can discuss more. I know I had a discussion with another gentleman the other night, last night, about 30-inch starters were his best ones. He's in the back of the room, so we can talk about why that may or may not come out to play. FCN, let's make sure that we're not forgetting that. Weeds, let's be timely with that. I've seen too many fields of succotash. You know what I mean, right? You guys are the South-ish, right? You know, if you had a market for that, that's a different story. But if we're not cutting corn and beans in the same field and getting the premium for it, let's not leave them out there. Certainly you get other weed issues. Disease, insects, weekly scout, just being on it, to really know what's going on. Fertility, the one that I've been pushing a lot with yesterday's talk and others. I mean, that all comes into play. There's many more. You can put water in the background, you can put environment, but really what it comes down to is to be intentional. Just being about your management. Not just throwing them out there and expecting to get great yields. You have to be purposeful with this, and that's really what I drive at, okay? So timely planning. You know, about a 50-minute talk on each one of these components I'm compressing down into a 50-minute talk. But timely planning. You know, this combination that you're looking at, heat unit accumulation as well as light interception to maximize your node production. If you're maximizing your node production, you're going to have an opportunity for more pods. You go through that. You got canopy closure, reproductive duration, reproductive branches, all these things that come into play. If you plant a bean on April 28th versus May 28th, they're going to be different. Same variety is going to be different in the number of nodes that it produces. Okay? When you look at a yield response because of planting date, it's the way the soybeans are growing and developing and responding to that growing environment that you created. Okay? So within the Midwest, and I would dare say it's probably our sweet spot is late April, early May. Okay, you guys probably maybe can get a couple weeks earlier than that if you like. All right, but that's our general sweet spot. I mentioned yesterday within Indiana and the Midwest, 50% of our beans aren't planted until after May 20th. Okay, that's a big shortcoming. Okay. Yield loss potential, so mid-May is usually when we start to see this drop off, about the 15th of May or so, we lose 3/10 to 4/10 of a bushel per acre per day after mid-May. And there's varieties, and I'll show some of this. I like to kind of use the take bullets, and I'll go into the weed bullets. But there's a linear decrease from early May at 3/10, 4/10 of a bushel per acre per day. So that means a 10-day delay could be 4 bushels. 20 days is 8 bushels. To understand a little bit about the physiology of the plant, you go through and how many nodes are initiated on the main stem. You go through this. So you got planting, so you put the seed in there. Already got 3, right? You've got the cotyledons, uniforms, and the trifoliates. Already there. Then you go through and develop the plant, and how much has been initiated. By the time the third trifoliate, you've got about 15 or so total nodes, trifoliate nodes, attachment points that have already initiated. By the 5th trifoliate, the vast majority have already been initiated. Now you're going to realize that later in the season, right? But if you're coming up with a later planting, and so by the 5th trifoliate you've already initiated all your nodes, but instead of 19 or 20, it's more like 16. Do you think you've got a yield loss potential there? Sure. Okay. I made a comment earlier about just kind of where we're at with overall development stages. So our job is really to get as many nodes as possible, get that canopy closed by the time we're flowering out the top, and then have a long duration in reproduction. Your greatest yields are going to come into the fact whenever you've got a long reproductive duration, okay? That slow fill period, okay? So here's just a scenario of planting dates we did West Lafayette. You know, this is our general Uptake. All right, we pushed it, you know, March 30th, April 13th, and this is how long it took to reach R1. Okay, R1's first bloom, right? These are indeterminates. How long it took. So these are calendar days, so 82 days, 68, 66, all the way down. First week of June took 43 days. Okay, why is it? Temperature change, right? I mean, we're warming up and we're at different heat units, right? Again, it's this combination of heat units and photo period. If you look at the actual calendar date, is this close to the day of the year? Right? So within the Midwest, we're hard pressed to get the canopy closed by the longest day of the year, but we want to have as much light interception as possible, okay? And as many hours of that as possible. For us, it's normally, we want to be kind of green to the eye by the 4th of July. Right, that's what we're able to shoot for. Maybe you guys are able to do a little bit better and catch late June, but I certainly want as much sunlight as possible. Right, and we look at late April, early May, they're coming in about the 2nd of July, R1. I want that canopy closed by the time I'm R2, so full bloom, so that's going to be a few days later. That's really your target, okay? If you're planting 30-inch beans and you're planting in the middle of April, you can probably do that. But if you're planting 30-inch beans in the later part of May, it ain't going to happen. And so that's when you start to see some major yield differences with some row spacing. Okay? This is one of many data sets that kind of show you that same idea of, you know, the node development, how that will start to drop off as you have later planting dates. Okay, this one happens to be, we hold out around 19 or 25 foliate nodes throughout most of early May. Then it starts to drop off. Same variety, and we're down by the 30th of May, 17 nodes. The first week, a week later, we're down to 15 nodes. You think you have a difference of 2 to 4 nodes, you're going to have a difference in pod load and a difference in yield. Okay? So whenever I say by mid-May I want them in the ground and up, I mean, that's that transition I'm talking about. Okay? Now, this is the exact same variety. We can have 18 to 20 nodes on our plants. Driving that. I've already made that comment. Green to the eye by the 4th of July. That's what we're shooting for. Did you guys, I'm just curious if this Midwest saying comes out to the coast a little bit. Grandpa has a saying about 4th of July. Dad or Grandpa, I want to tap. You know, now we can go ahead and say by the 4th of July. We're talking about
out in the Midwest. And so a lot of the solutions are pretty quick.
You guys can probably be a little bit earlier on that. And just give an idea, a 15-inch row versus a 30-inch row. Now, we don't have some weather issues. We don't.
Better season.
Within the Midwest, this 30-inch row, can you idea how much longer it takes to close the row versus a 15? Give me a day or a week count. How many more days? 10 days? Any higher? 2 weeks, so 14 days? Any other takers? 25 days. 25 days. Do you think that makes a difference? You betcha. I got a little Wisconsin coming out of me now. I say, we betcha. Get you all back. So before I came to Purdue, there's what I call the kitchen sink 1.0 study. Agronomists across the U.S. different approaches, right? And this is average over 3 years, all these locations. And they did a myriad of treatments, but I'm just going to concentrate on these 4, on this idea of canopy closure and the idea of row spacing. All right? Across all these years and environments, so all the way to Louisiana, full and wide, 30 inches is what we're talking about. Average 54 bushel. Now, that ain't anything to write home about, but the idea of the treatment effect is what I really want you guys to look at. So, a lot of people went to 30-inch beans because now we're not going to have wheel track damage. We can put the sprayers in at R1 and R3 and not have any damage. All right, but again, as far as just a yield response from wide rows to 15s or new rows, this intense management, the kitchen sink that they threw at it, gained about 2 bushels. Economics never played out with that, but just agronomically, that's what it gained. If they just simply planted timely on these narrows, so 15s, they're 56 bushels, not anything else. Okay, versus that control at 54. Now whenever you bring in with a narrow row, 15 is what we're talking about. Probably did a drill or 10-inch, but the idea is 15 or less. 1 bushel mark. Okay, that's synergy. Okay, so you get canopy closure, what we're really driving after, and then the combination of some of these intense management. So it became more of a 6 to 7 bushel response instead of only a 2. Okay, make sense? Combinations we're talking about. Just to show the idea that node response also plays out in a pod response. Okay, this timely planted versus something that's later. You're holding on the nodes, right? We held out about 19 or so until the middle of May, and then it starts dropping off, right? The same thing happens time and time again. Okay. I've had these conversations over last night and this morning. How many blooms, or what percent of our blooms do we lose on soybeans? 60%? 70%? Times 75, 80. Okay. So we're setting up the stage to retain as many flowers pods as we can. Certainly water is going to be a big player in that. But we want to make sure we get the water to R3 and beyond. All right, so I'll continue down this planting dates conversation and then transition to some of these high management studies. I mentioned yesterday we played with some of these old soybeans to new and how the new ones are responding more favorably to that. So just kind of want to share that and that work. So out of the maturity preset, so at these 60 cultivars from 1920s to present, one of the things we grow stage these all season long, one of the things that kept coming out is that the modern ones are reaching R1 about 5 to 7 days. Same. So you're starting to get there faster, okay? So hold that thought. Secondly, the duration, so from R1 first bloom, you're getting close to signs of maturity, is actually longer as well. So you're reaching R1 faster with the modern line, and you're holding on longer, 15 days, okay? So do you think genetics and the modern lines, they're gaining a lot of yield? They're in reproduction a lot longer now, okay? We turn off hot and dry, we don't have the water, okay, that window really gets shortened, all right? Early May, June, different. Okay, that's a 10-day difference in duration of reproduction. Now, each day in July, early July versus early August, are those days equal? 24 hours. Are they equal? It's different. So you got heat units, you've got day length, right? You got some, water issues again. So again, a day is not equal, even though I'm just now saying 10 days shorter. Yeah, it's 10 days shorter. I'll show some data on that. Overall, this is timely planted. It's going to be in green, and the black line is going to be a late, early June across these release here. This is what I was referring to yesterday, that you have divergence, right? You just follow that line. The early ones that are pretty tight, planting date.
Pretty quick.
Average down 8 bushel, but it could even be more when you look at the spread. Okay.
Really good.
We've been around with planting dates and some of the high oleics and Plenish and a few others, but I've kind of masked that here just to talk about planting date effects and variety of response. Okay, we did 5 planting dates, tried to get out late April, ended up with the 2 years we had. First week of May is the place we could get out, so that's kind of the top mark for us. You got 3 varieties over these 2 years, they're kind of holding out, and then they start dropping. Okay, this is percent of max yield. So then you have that one variety, straight linear decrease. Okay, straight linear decrease from May 6th. Okay, again, there are some variety by management interactions going on. And so again, timely planting, the genetics is a big part of that, and then to understand how those respond. Okay, we're talking 10, 12 bushel differences when you look at May 6th versus June 6th. Okay, huge difference. All right. This is one where I don't think we do enough on the discussion with duration. Same varieties.
Lots of solutions kind of
That's why July 6th is extremely late for us. Normally, our freeze normally comes around October 9th. And we're able actually to get these matured. Okay. So just understand that the yield effect we'll see, as a late plant, it was an early freeze. You have this nice heat now. I think we all can appreciate. Green's going to be good and red's going to be poor, or it's going to be shorter. All right. So day length, 55 days from R3 to R7 with timely planted. How many people at 54 days, 1 day difference isn't going to make that big of a difference? How many think that 1 day is not going to make that big of a difference? I'm baiting you, right? 1 day, look at that. Oh, shoot, that's not going to be different. So one calendar day is not the same as those two periods. Okay? Certainly when we get into the June and really down days for that R3 to R7. Yeah, so these were all the same maturity group. We had 4 in the background. These were early 3s that we're looking at on this set. We've done it with late 3s and early 4s down in the south part of the state, but these are early 3s. 4 varieties average in the background of that. I don't have the data yet. So then, to kind of give you an idea of that they're not equal is the heat unit. So we went ahead and put the heat unit to it. So that same period is a little over 1,200 heat units. Again, super late, 832. Major heat unit differences. And again, those are going to play differences in your overall yield. All right. This one, I think, probably sends a message clearer than anything else. All right, so these are the hours across 3 of our locations. So you go to the northeast, that's going to be our black. Acre, that's our West Lafayette farm, West Central, and our southeast farm. So you see a little bit of latitude difference. You've got the calendar dates across the bottom. So again, we can all appreciate the longest days. And our idea is to get the canopy closed by the time the flower now stops, utilize all that sunlight. So here's a 5 plant dates. Got the bar set up, the same color scheme earlier. I'm going to start when I planted it. I've got R1, R3, first pod. I'm lining up with the data to give you an idea. That's what I was just talking about, R3 to R7, and hours of sunlight. That's the timely planted bean. Okay? Follow it through. May 22nd. June 4th. 24th of June. 6th of July. Does that send a message? You know, those calendar days at 55, 54, 48, I mean, they're not all equal. Just look at the hours of sunlight alone. Okay? We're a factory, right? You guys have always heard that term, right? Our plants are factories harvesting sunlight to create photosynthase. If you don't have the hours for it, guess what? You ain't producing photosynthase. If you ain't producing photosynthase, what aren't you producing? Grain, right? So, everyone got a good picture of that? They like it? Good? Okay. So going back to this timely planting, again, it's no development, it's pods, reproductive duration, canopy closure, reproductive late April, early May for us. You guys can probably go a week or 2 earlier than that. Basically, when you're getting the corn planter out, you should probably get in the soybean planter out, or give it about 5 days. And then do all. Let's be honest. That's really how it goes. Corn responds to what? Heat units. Okay. So we've got heat units and photoperiod to play with. Okay. Loss yield potential 3/10 to 4/10 of per acre per day. Again, that's mid-May generally, but there are varieties that it's a straight linear decrease from first week of May. Okay. Planting date. I wanted to hit this a little bit. I know it's nothing new, but at the same point, just understanding what kind of differences we truly get by a delayed planting is really critical. Okay. Switching gears a little bit to the kitchen sink 2.0 is what I'll call it. We had a nice fancy name. When we go for dollars, right? You got to come up with some cool name, and so I came up with this one: Systematic Optimization of Yield Enhancing Applications, SOYA. That's what the thing 2.0. A couple years after I made to Purdue, we got pretty good representation. This gives you an idea. From 2012 to 2014, we did 3 years of this across north. We got Minnesota, Wisconsin, covered really well. A little bit of Iowa, Illinois, Indiana. We come down to Kentucky and Kansas. All a little bit. Okay, so a pretty massive study, but yeah, at the same point, somewhat contained. We're not really pushing down to the Mississippi area or Louisiana. That system is different, right? And so I felt like, and I think the group felt like this was a little bit better contained type study. Okay, 20 locations. There's a lot here. All right, we did 3 different studies, but I'm going to just kind of share the majority of one and a part of a second. Okay. All right, so here we're going to take the time. This is the kitchen sink, right? You guys either get asked to say which one product's a silver bullet, or is it a combination? Across the combinations that are coming into play. What's going on with the seed, what was going on at V4 timings, R1. So as you work down this, the blue ones are going to be kind of these individual components, like number 2 antioxidant. At R3, okay, that was Bioforge. I had to be PC and just say antioxidant, but it was Bioforge. Okay. Treatments, whether you just had a fungicide and insecticide, insecticide and a biological, fib. I won't say anything more than that. That was ratchet, is what we used. Multiple nutrient type foliar product. The foliar, what we're talking about with that one? Close. Cobra. Yeah. We burned the living tar out of it, right? What's the concept of doing this, burning the tops out? You're stressing them out, so there's 2, right? You're burning out the tops, and the idea is maybe I can get them to branch. That's one concept. The other one is to stress it out. So there's some documentation with Cobra. What do they call it? Systemic acquired resistance. So it's basically like when you get a cut, your body has the hormones, and it just kind of to fight that. And so you have that same kind of response as what they talked about with Cobra. But that was twofold idea. So we put out 12 ounces and a quart of COC. Okay, yeah, we burned the tar out of them. Never burned out the terminal though. We really offered them good. All right, coming in fungicide. So talked about some of the strobies to start off with, and we moved to multiple products, headline, Axor, and Endura. Well, at this point, it's been a few years. Insecticide, just a pyrethroid. All right. Combination of the 2. Nitrogen. At V4, we did 70 pounds of nitrogen, half urea, half polymer coated. So I did a little shot in the arm, but that one. Make sense so far? Okay. And if you haven't learned, I call the same. Soya is going to be kind of this combination of everything. Okay, so we've got the nitrogen, add all the R3. And then the concept is, okay, maybe it's not a single product like those blue lines. Maybe it's the combination. Something you subtract out of that would be the main difference in terms of gain. Kind of emissions. So I kind of faked it a little bit on number 13. 13 add to it. Okay. And then the other ones
Bird, you know.
okay. So the soya we removed from the whole soya, we just removed the fungicide, and then the last one is we removed fungicide and insecticide. So the idea is whenever you start to look at these yield numbers, if the yield drops with one of those red bars,
That makes sense.
that one thing that one thing we added with the Cobra was the one that made the difference. That makes sense? Okay. So if you see them at the same level as the highest yield, there's no difference. That one that was subtracted out really wasn't the player. Okay. So trying to catch a system as well as individual, quote, silver bullets. All right. Now I'm going to represent this in three ways. I'm going to look at large yielding environment, high yielding environment, and low yielding environment. Before I get to that point, do you think that there's going to be a difference? That intense management, these kitchen sinks. If you do, tell me. High yielding environment is going to respond.
Earlier,
We think that poor yielding environment really needs everything to bring it up. Not as many. I got a few. And what about the average? It's average, right? Yeah? Yes, no? Okay. Just hold those thoughts. Gives me a flavor for the... Here's going to be the average yielding environment. This is the 3 years after all the locations. Same color scheme. Hopefully it makes a little sense. The only thing that I'm playing out here is contrasting the black bar, that's the untreated control, versus anything that was a higher yielder. Okay, there's going to be other differences within this graph, but just for today's discussion, if it's got that above it, it means it's a higher yielder than untreated control. All right, these are average yielding. We're averaging 60 bushel, okay, so not bad. When we come into some of that early season, again, that's kind of how I got season for us. The seed treatments really weren't playing out. Ratchet didn't do much. Foliar fertilizer.
What nitrogen applications? Now I know.
We'll say, sorry, it is different too, by the way. I will say with the Cobra, we did catch 1 or 2 years where we got it. Out the terminal, delays develop to keep.
Put about half of it. That's later on, okay? Up front, at planting or before planting, and half of it later on. All of that is your low capacity and soil nitrogen.
You're going to have. So that's where we would see it play out, and I did see it from time to time. But overall, no. You tap the foliar fungicide, insecticide, R3. For this data set, the R3 insecticide was playing out more. Combination of the two brought it up, so we're looking on the order of bushel over these 3 years and all these locations. Okay. Nitrogen really didn't do anything for us. I will say I had individual sites that did have a response, and then those that didn't. Okay. I've had this conversation as well. It's those growing conditions that we've got to figure out where we're going to see a response. It's not an always kind of situation. So the kitchen sink, everything thrown at it, so it was the highest yielder, so we're at 64 and change maybe, 64 and a half, so about a 4 bushel difference from the untreated control. All right, and then coming out with these red, these omissions, these are all equivalent to beating out the untreated control. When we dropped out the fungicide and insecticide, it dropped down from a 64 and change to a 62. Okay, so that fungicide insecticide combination really did kind of add a lot to the table for us. All right, if you were putting numbers, economic numbers to this, that doesn't pay. Okay, just so you know. Okay, agronomically, sure, we get about 4 bushel. Okay, so 60 64-ish. All right, 4 bushel. Remember that number. This is the average yielding environment. Okay. High yielding environment. So we class high yielding environment anything 76 bushels or above. Okay. So our untreated control was bushel. Naked seed, timely planted, narrow row. So what made the difference for us? Mother Nature. We're not on irrigation. But Mother Nature. Okay. This is the frustration of soybeans, isn't it? Right? That doing nothing else. This year, I planted April 20th beans. John Deere's Exact emerged. I was playing around going 5, 7.5, 10, 12.5 miles an hour. We hit spots that are 100, 120, 130. And the only thing we did was plant timely. And these were even 30-inch beans. Mother Nature was beautiful for us. Okay, so that makes a huge difference. I want to make sure you guys understand that if you don't already. All right? High yielding environment, so you in the seed treatments. No surprise there. Insecticides. The soil take down about 85 or so. So 80-ish to 84, 85. That difference? About 4 bushel. Your call slide before? About 4 bushel. So it doesn't matter in terms of average yielding environment or high yielding environment, at least from this data set. And it's a pretty strong data set, okay? Didn't matter. Dropped out. The nitrogen didn't do anything for us in these as well. There's a lot of that, okay, the high yielding environments, that's where you're going to see the nitrogen response. That wasn't where we were seeing it. Insecticide, those were going to say the Cobra added to it, and so you dinged it. So, right? was playing out. Okay. And these are pretty good years. So 2013, 14 across West Lafayette, we had a couple of those as well. Low yielding environment. Okay, we're talking less than 48. All right, nothing. You look at that, it's still pretty intriguing to me that you go from a 40, let's say 41 bushel to the 4 bushel? Huh, fancy that. Okay, so it doesn't matter with that combination. Okay, again, the individual, the red ones here, the emissions weren't really playing out. So right now, I want to hear what you think the take-home is before I give you the full explanation. This kitchen thing 2.0.
The program.
Really, insecticide was driving it, and I want to share a little bit of why that is. Okay, before I get there, I'm ahead of myself. 2012, we had 5 locations out of the 20. 13 and 11. 2012 was our drought, by the way, just in case for that one. It was nasty. 2014, 12 locations out of the 20. I responded. Here's what really starts to play it out, in my opinion. The north, so the Minnesota, the Wisconsin, the Michigan, 15 out of 21 responses cite years. Central, so that's going to be Iowa, Illinois, Indiana, 5 out of 18. South, that's going to be Arkansas, Kentucky, Kansas. We're looking at 8 out. What's really driving the boat? The north, when you see some of these responses, especially with insecticides, wasn't there any yield level by management interaction? Come on, get into there. We teased it out another way. Looking at those that had a positive response with foliar insecticide, look where those are playing out. All in that northern tier again, right? So their pressures, aphids are coming pretty early. All right, we see aphids till the season. I haven't had an aphid here in a while. But I mean, they've got some more pressure, and so that's why. And some of the responses they were getting weren't just a 2 or 3 bushel responses. They were getting 10 and 11 bushel responses with insecticide application. Okay, so now you can kind of see where this really pushed this full data set to that level. Okay, just to kind of get that understanding. I will say this is my home area, West Lafayette. I continue to see quite a bit of response on insecticides, at least in my area. I think it goes back to some of our pest complexes, how I look at it. I'm not hitting individual pest thresholds. I'm hitting bean leaf beetle and stink bug and Japanese beetle. Not individually, but I just have this sense that we're getting a complex that's really pushing us to getting a yield hit. Okay, and I get it time and time again. So that's West Lafayette and a couple of other locations. I'm probably getting a 4 to 5 bushel about every time, even though I'm not at threshold individually. So that's something for our colleagues, our IPM guys, our entomologists to kind of think, okay, should we come up with a pest complex or not? From what I've seen, it's something to consider. Seed treatments for us really didn't show any value across these sites. I will be quick to say we definitely have areas of Indiana, I know other states as well. We've had Phytophthora issues, we've got Pythium. It's just knowing those fields have got those issues, especially if you're planting timely, like I say, or what's considered early for the area. Boy, a fungicide seed treatment, making sure it's got the activity that you need, is a pretty good player. For this study, we're playing out a little bit more. Any questions on that before I wrap up that one and then switch to kind of some of the fun stuff I'm starting to see with this year's study? Any questions on that so far?
And that's the last that you have.
We've looked at the idea of, is there a variety by management interaction? So the idea is that you've got those that are classed as what? The workhorse, right? Yeah, you had a question?
Somebody that kind of stands out from the crowd and does a good job with highlight. And to contribute again across the store. So they would probably the work that they do and the work that you do. I mentioned it earlier. We don't know exactly what but it might take the form of like a booklet.
Parchment K. And you still see what? Potassium deficiency. Full moisture. You're just shunning so much to the seed that you're getting this temporary potassium deficiency. And I've seen it time and time again because there's just such a strong demand. And so it's pot fill. Yeah, it's R4, R5, R6. We see it. And so some of the other responses, I think. All right. Hopefully I answered that a little bit. Yeah. No. Okay. Just applaud it then. That's all I ask. I have an ego. No. All right. So anyway, the question was variety by management interaction. And so in other words, we call it defensive. We call it workhorse. Do those respond differently to those? So the one's going to be untreated control. We did that SOYA complete, and then we did SOYA minus foliar fungicide. Again, that's all right. And that's how we kind of played it out. So what's interesting out of this, and just to get to the take home of that, is only 3 out of 53 combinations was there ever a cultivar by input interaction. In other words, only 3 times were there a variety influence on that management interaction. Okay, it's pretty low. I was anticipating a little bit more. Okay, but again, that's a pretty sizable data set. As far as okay, sure, there's going to be differences. We've already talked about that. Inputs, yeah, there's going to be differences, and what they were seeing was the same thing. I'm not going to belabor the point that you go from the untreated control to the SOYA. It was again a 4 bushel difference. Okay, you don't need to see another slide on that. All right. So just in case there's a question on that. When we did see the yield increase, it was an increase in seeds. The graph was counting seeds. I really think it's not seeds. and then seed size. All right, so that was kind of the SOYA 2. Now to transition to what I was giving you a little bit. Holy cow, what time did I finish? 5 minutes? You got to be kidding me. Okay. All right, so old soybeans to new, I'm not going to belabor this, but just to make the point that we're seeing major differences later in the season, right? And that we were thinking about there's more going on, R6 and beyond, all right? So let's, so this is what I was driving at yesterday, and then to kind of finish it out. 1960s, we had about 60% of the phosphorus in the pods and seeds, gaining about 75. And then we've got this, linear increase, right? At R6 to 95%. So there's a lot of phosphorus getting put into the seed. And so that was really where we decided to drill down on this management. We looked at the phosphorus component of that. The threes are showing, okay? So that's why we focused on phosphorus and started to piece this apart. So, all right, 6 cultivars by 6 fertility foliar combinations, which equaled 36 treatments. It's a lot, okay? So we had 2 from the 70s, 2 from the 90s, 2 from the 2010s, crossed with these 6 fertility foliar combinations. And we had a second study, the same thing on maturity group 3, okay? All driving with that. The fertility foliar combinations are here. So we've got color scheme, hopefully helps you a little bit. Untreated control. I actually got a good field this year. It wasn't the 10 parts per million phosphorus and 85 parts per million K. It was actually good fertility, so that wasn't an underlying problem. So we're major there. We broke it down so we could start to look at the phosphorus, and then I brought in some of the sulfur as well. So we had MAP, all right, had a little bit of nitrogen with that. 8 was our target, P205. 20 pounds of sulfur, a little bit of nitrogen. Then we brought in phosphate and ammonium sulfate all up front, worked in before planting. Again, same target, 80. Then we added in blue is going to be the untreated plus the foliar. And then we just picked out one of these, triple superphosphate, AMS plus foliar. The foliar was an R4 application. We're looking at 4 ounces and 1, 2. Okay? So the idea is, okay, enhanced fertility, is that going to see any differences across these release years, and is there going to be an interaction? All right, so with the few minutes I've got, here's how it's laid out. I told you yesterday, again, my stats software isn't up to date, so I decided to do a nice, pretty color heat map for you, okay? 36 treatments, this is probably the best way to show it right now. So maturity group 2, we've got the release year, so 1914. The combinations are set up so that MAP, triple superphosphate AMS is going to be in the. Now I'm going to blank each one. So the TSP plus foliar is going to be here in blue. Plus foliar is going to be off here to the left. Okay, you're about to get wild, right, with a lot of numbers. Yeah. But the colors should really start to step out to you. Okay, we had high yielding environment this year. I'm talking we had 95 bushel beans in this plot. Okay. Very good yield year for us. Best year we're going to have as a state. What jumps out at you the center? Fertility aspects. So basically, that red or orange, you're the low. If you're the green, you're going to be high, right? What jumps out to me, so here, we range from 53 up to 83 bushel beans across the release year. TSP and AMS, we're around the 50 mark, up to 85. But the triple superphosphate ammonium sulfate was the red. It was at the bottom. Okay? That was interesting just on fertility alone. The MES 10, okay, it was kind of a mixed bag. From untreated control over here to the untreated control plus foliar, okay, we get some yellows and greens. Okay? Look what happens over here. Superphosphate, AMS, and foliar. They're at the top every single time. Except for this one, which is still pretty close to the top. Okay? If that doesn't mean anything to you, I tried to make it a little simpler as far as a percent change. This is the change that we're talking about. 15, 16, 18, 11, 14% change. Actual numbers, that's a 10 bushel change. That's a 9 bushel change. That's an 11 bushel change. Amazing. When you have the same foliar on untreated control, we get a 3 bushel. Okay, so this is where, again, this is brand new data. I've just kind of started playing with it. It just makes me a little excited. Okay, we've got something playing with this enhanced fertility. What's foliar combination? What's going on? Is the sulfur helping out, with leaf retention, photosynthesis? And then you bring in the strobe. We can talk about that. But it's really just kind of interesting that where we're driving with this and this combination. Tube 3, through release year, foliar treatments plus fertility. Let's show again. This combination is really interesting. I don't have all the answers. I'm just going to some observations. Look at it on a percent basis. Untreated control change with foliar, hardly anything, right? You bring in TSP+, plus the foliar, we're looking at 16, 27%. We've got a 15 bushel change there. On the set, on the other guy. So when we look at it together, that's what we're talking about. Right? So I'm not saying I've got all the answers, but there's some fun stuff that's coming out with this fertility, enhanced fertility plus some foliar management. Okay? And we're going to dive into more. My student on this one, bless her heart, we are taking basically weekly samples from R4 to R8 with all these. Looking at seed fill rates and see how that's changed. Because we know so much has changed R6 and beyond, we're going to have some pretty good answers as far as how this really changed on these management combinations with the okay. So it all comes down to being intentional, all right? And I appreciate your vote this year. I'm around if you guys have any questions, but I know it's time to change.